We would like to be able to determine higher derivatives. So instead of just f prime, we would like to be able to determine f double prime, f triple prime, f fourth prime, f fifth prime. Once we get past 3 apostrophes, we just start writing 4 and 5 on top. And the fact is, for most of everything that you do, folks, we are going to stop at just the second derivative most of the time. Okay, most of the time we'll just stop at the second derivative. Okay, but this is a good example. Love this problem. I look forward to it every year. These are 1, 2, 3, 4, 5. Let's see, 1, 2, 3, 4. I got 5 up here, right? I got 5 graphs, and so we don't need to do the last one. There's not actually that one there. But it turns out one of these is the original function. Yes? Oh, sure. Rosa, do you want to move over by Danny and partner up with her?
Oh.
Or Danny, do you want to move over by Rosa and give her some company?
Oh.
Oh, wow. Okay, we went that route. One of these is the original function. One is the first derivative. One's the second derivative. One's the third derivative. And one's the fourth derivative. I would like you to look at those and see if you can come up with which one is the original function. Okay? Take about a minute and a half. Talk to the person next to you. Maybe you remember a little bit about derivatives, you know, kind of where they're equal to 0, where they cross the x-axis, positive, negative, things like that. Talk to the person next to you. Try to take a minute and a half and come up with a thought here. Go ahead.
What's my original thought?
It's like negative.
Yeah, because
It's
like that was
starts-
going to be a parabola from that.
It starts really positive. Right. Wait, it starts really negative.
I don't
Because I'm just thinking like
nightmare.
this, get rid of this one, and show this one. It's really negative. I don't know. Just gonna put this one.
Because, like, you know how you take a derivative and it goes down?
Yeah.
But then x squared to x cubed over x squared.
Let's stick with the original topic.
know. Then the bar's not even negative. Wait, because it is a derivative. Why are they called these?
It's someone's birthday.
So what do you think? Which is the original one? Who's got a guess? Yeah?
The blue one,
The blue one's the original one. How come?
because it's looks like a parabola.
Because it looks like a parabola. Got it. Got it.
I second.
Can we say something more intelligent about it than just that, please?
It like starts at 0 and it I don't know. Because the other ones don't cross 0. Or the x. Never mind.
She is right that the blue one is the first function. Okay, you guys said it as well? But let's try to come up with a definitive reason why. The blue one is the only one that has a derivative of 0, right? It is the only one that has a derivative of 0. That's not why it's the first one. But if you look at it, okay, this one has a derivative of 0, and it looks like the red one has a spot where it crosses the x-axis at that same location. You see that? Whereas the blue one crosses the x-axis here. Is there any function that has a derivative of 0 at that spot? No. So the blue one cannot be a derivative. The blue one can't be a derivative. So there we go. We start with the blue. And we say that f is equal to the blue function. got f right here. So now take 15 seconds. Which one is f prime? Talk to the person next to you. Which one is the derivative of that? All right, the derivative of f prime we said was the red one. 15 seconds, which one is f double prime? Which is the graph of f double prime?
A double.
Okay, which one is it not? It's not the yellow because the derivative of the red function is always positive. Therefore, the graph should always be above the x-axis. So it's either the green or the purple, right? So here we got to do just a little bit of thinking. Maybe you take this spot right there and you say, well, if I were to draw a tangent line, looks like the slope would be about 1. So does the green graph have a value of 1, or does the purple graph have a value of 1? It looks like the green graph has a value of 1, doesn't it? So the purple one's just too steep at that spot. So we're going to say that it's the green one. And you would say that the derivative of the green one is always negative. So therefore, it must be the yellow one would be that derivative. And then finally, the last one is going to be, or we'd say, fourth derivative. My bad, getting lost here, sorry about that. No. The fourth derivative is equal to the purple. Now, I think for a lot of students, when they get to this part of the assignment, they struggle to figure it out right away. You don't have to necessarily figure out the very first one. Just start making guesses and see how you come on out. Don't be afraid to try, okay? It's not always just one way to go about it. Flip it over. We have the rest of this to go through. It says find the first and the second derivatives of the following functions. The first derivative is, shout it out, what do you got? 4x cubed. And that used to take us 5.5 minutes to do. The second derivative, oh boy, this will be challenging.
We got this.
12x squared. How do you say it? There you go. Higher derivatives. How do I take the derivative of this one? Chain rule. Isn't it wonderful to have the boxes? Or would you rather multiply out 2x minus 3 5 times? No? That's overrated? Yeah. Whoever says that's fun, they got a different idea of fun than we do. I got the first derivative.
Next one.
Shoot, how do I do the next derivative?
Chain rule again.
Oh, chain rule again.
Oh,
10u to the fourth, 2x minus 3. So I've got 80 times 2x minus 3 to the third. Not too bad, huh?
It's about to get worse, I can tell.
How about the next one? Chain rule. So I've got u to the 1/2. And what's the derivative of u to the 1/2? Yep, so you've gotten used to that now. We're at that point where everybody has that memorized. And then we multiply. 1/2 times 2 is 1. So I get 1 over the root of 2x minus 3. I have two options for finding the next derivative. What would be one option? Quotient rule. What would be the other option? The chain rule. Yeah. I like the chain rule instead of the quotient rule. So I will set up u to the negative 1/2 and 2x minus 3. Since the square root's in the denominator, it becomes u to the negative 1/2. and then the 2x minus 3. I take the derivative and I get 2, and here I get negative 1/2 times u to the what power? Negative 3 over 2. Notice that the 2's will cancel, and I get negative 1 over the quantity 2x minus 3 to the 3/2 power. That wasn't too bad, Rosa, was it?
About to get worse.
Scared of the next one?
I'm scared, yeah. Scared of a lot of things.
Are you a scary movie person?
Yeah.
Have you seen Silence of the Lambs?
No, I haven't. I know it's a classic.
It's a classic, gotta watch it. You've seen
Maybe
Danny?
tonight I will.
I have. Wasn't a fan, honestly.
You weren't a fan?
Mm-mm.
Okay, well, you know, I mean,
Yeah.
some people don't like chocolate, you know, I mean,
That's okay.
everybody's
Or
got
for the
their,
rest of
yeah,
us.
go ahead. What rule do I use here? Product rule. The derivative of theta is 1 times secant plus theta times, what's the derivative of secant? Secant of theta, tangent of theta. That wasn't bad. Let's find the second derivative. What's the derivative of secant? Secant of theta times tangent of theta. Plus, oh boy. What's that?
Math.
No chain rule. Only the product, twice.
Oh, nice.
It says times and times, product rule twice. I'm going to, for the sake of this problem, I'm going to call theta f, and I'm going to call secant of theta times tangent of theta, I'm going to call that g. And so I have the derivative of theta is 1 times secant of theta times tangent of theta. Plus, now I have theta times, and now I need the derivative of secant of theta times tangent of theta. And that requires the product rule. And so now I will call secant f and tangent g. What is the derivative of secant? Secant of theta times tangent of theta. Times tangent of theta. Plus secant of theta. Times, what's the derivative of tangent? Secant squared.
Oh boy. Can you imagine trying to find a third derivative of that?
Yeah, I like, hey, that's a good idea.
No.
We've never done it before. Should we find the third derivative?
It's okay.
Okay. I'm gonna try to clean it up. I would accept that as an answer on the test. I'd like to clean this up. I've got 2 secant of thetas, tangent of thetas. Everybody agreed?
Yeah.
And then I've got plus theta times secant of theta times tangent squared of theta. And then plus theta secant cubed of theta. What do they all share in common? They do, don't they? They all share a secant, don't they?
Take it out.
So I am going to clean this up a little bit. I'm going to take out a secant. And I get secant of theta times 2 tangent plus theta tangent squared of theta plus theta secant squared of theta. That's about all we can do. Oh, wait, we screwed up, didn't we?
Yeah.
Let me see it. Or maybe we didn't. I was looking here, I thought we missed a theta. I just want to check again. So we have, nope, that theta's right there. Yep, no, we're good. Yep. And so that's, it's really about all we can do with it.
Oh, I see.
A lot of thetas in there. Makes it a little complicated. Last example. 9x squared plus y squared is equal to 4. First question. What does this look like as a graph? Do you recall? Close. An ellipse. If you were, you don't have to write this down, but if you were to divide by 4, you would get 9x squared over 4 plus y squared over 4 is equal to 1, or in other words, x squared over 4 ninths plus y squared over 4 is equal to 1. So it turns out this is an ellipse. It stretched 2 units in the y direction. It stretched 2/3 of a unit in the x direction. But that's the form that we looked at ellipses last year. Is an ellipse a function? No, it doesn't pass the vertical line test, does it? And up until last Friday, we didn't know how to find derivatives of things that were not functions. But now we know how to find derivatives easy. We just use implicit differentiation. And implicit differentiation is really helpful when you're working with some of these higher derivatives. What is the derivative of 9x squared? And what is the derivative of y squared? 2y prime. And what's the derivative of 4? 0. And now we work on solving for y prime. And so as we subtract the 18x, I have 2y, y prime is equal to negative 18x. And I divide by 2y, I get y prime is equal to negative 9x over y. Piece of cake upside down. Now we'd like to find y double prime. What rule do we need to use to find y double prime? The quotient. Let's be careful with the algebra. The derivative of the top. Negative 9 times the bottom minus or plus minus the derivative of the bottom y prime times the top all over the bottom squared. So, as we gander at this, we have our y double prime is equal to our negative 9y, and it would be then a plus 9xy prime over y squared. Only we can't have a derivative inside a derivative. You see this? So what can I do to get rid of the y prime?
Can you separate the fractions? Or
What is y prime? Negative 9x over y.
Oh my gosh.
Right? The problem gets really cool. It really does. Wait for it, and you'll be very, very pleasantly surprised. I got y double prime is equal to, I'm going to raise negative 9y over 1. And if I multiply these two together, does everybody agree I'm going to get a negative 81x squared, x squared in the top? So it's a minus 81x squared. And then what's my denominator? Just y. All over y squared over 1. So you can see once we insert that negative 9x over y, it becomes a complex fraction. In order to simplify a complex fraction, you need to have one fraction top, one fraction the bottom. So I need to create common denominator, so multiply top and bottom by y. And in the top, we get a negative 9y squared minus 81x squared over y squared over 1. Now what? And I get negative 9y squared minus 81x squared over y cubed. Now here's where it just pays to just have a little curiosity. What's your curiosity say at this point? You say simplify, what do you mean? Okay, so factor out a... Now what happens if we factor out a negative 9? What happens? Does that do anything for us? We get a positive y squared plus a 9x squared over y cubed.
I'm not seeing it.
That's what it is.
Say it again.
That's what it is at the beginning.
So what is what at the beginning?
Oh, I see.
Y squared plus 9x squared? That's this?
Yeah.
Which is just equal to 4.
Oh.
Look at how cool that is. So we came up with that exact thing, which is 4 in this problem. So that we can replace with just 4. So in the top, we get a negative 36 over y cubed. Isn't that sweet?
Sweet.
Yeah. I told you the problem would not disappoint. Brought joy to your life. Once again, math delivers on election day. It says, I will bring you joy. If your candidate does not win tonight, just know that you were able to find the second derivative of that ellipse. How beautiful. Hey, you got the rest of the time to work.
Wow.
What the answer came up?
I mean.